Welcome again to Back to the Basics, getting started with Amazon S3. My name is Matt Sidley, and I'm a Principal Product Manager here on Amazon S3. When I talk to customers about getting started on Amazon S3, the framework I like to use comes down to three pillars: storing your data, securing your data, and protecting your data. But first, I'm going to provide an overview of how to think about S3 from a system perspective, as that will provide the context and into our framework, and will really provide you the background information that you need to know so that you can apply the framework. So as I mentioned, one of the key things that I always start with is a view into how AWS builds its infrastructure and regions to deliver the availability, durability, resiliency, and performance you require. Each AWS region is made up of a group of availability zones, or what we call AZs. Each of those AZs is a standalone data center or a cluster of data centers on a single site. And they're typically a few miles apart to isolate them from local failures like fires, floods, or power failure, but they're never more than 100 miles apart so that we can retain super high performance for S3, even when we're protecting that data by writing it across multiple AZs in an AWS region. So as I mentioned, one of the fundamental primitives of AWS is the region construct. Many other AWS services have you select a specific AZ to use that service. For example, if you're launching an instance in EC2, you might choose a specific AZ. Or if you're spinning up a cluster for your EMR workload, you would choose a specific AZ likely. S3 is a bit different because it is a regional service. When you store your data in S3, for our regional storage classes, S3 automatically distributes that data across at least 3 As within a region. In fact, we don't send a 200 response until your data is successfully stored across multiple AZs in that region. Spreading data across a region and that regional model for S3 provides inherent characteristics like the durability, the availability, and the performance. This is significantly different than you might experience if you're running your own data center on premises, where you might interact with a single file server, or you might store your data just within a single data center. So now that we understand kind of the framework or the context behind how S3 works as a system, we can start with our first pillar of our framework, which is storing your data. S3 has a concept of a storage class, which is set at the object level and has characteristics like performance, price, and availability. Amazon S3 has a number of storage classes to choose from for every imaginable use case. Whether you have demanding performance needs, data residency requirements, unknown access patterns, infrequently accessed data, or archival needs, S3 has a storage class that is optimized for your data access, durability, and cost needs. So let's go through a few use cases that you might have and how you might choose a storage class for that use case. So first, let's start off and let's say that you have a website and you want to serve content out of S3 to that website. Data, as you can imagine, is frequently accessed by users around the world as they load the website and that content is loaded in. So if you know that your data is active and frequently accessed and may be deleted within a month, you should use S3 Standard as the best choice because it's designed for 99.99% availability and has low millisecond latency. But let's say you have a slightly different use case, and now you have a photo sharing app where end users upload photos from around the world, and that they upload them, but they're actually infrequently accessed because oftentimes people take a picture, they might share it once or twice, but then it just sits there. And so they have these infrequent access, but they do need that low latency access when you need it. You can imagine someone's on a phone and clicks on a photo. So in that case, you should probably think about using S3 Standard infrequent access. If you know your data is less frequently accessed and not deleted within a month, you can use S3 Standard infrequent access and save up to 40% on storage costs compared to S3 Standard. Or maybe you have a different use case. Maybe you have log data. Maybe it's click-through data of what's going on your website. Maybe it's sellers data. Maybe it's data of security and access logs that you need to keep around for long periods of time. And it's access, but then you have requirements that you need to keep it around, and it can be offline and it's rarely accessed, but it's available if you need it. For those use cases, you should consider using one of S3's archival storage classes, Amazon S3 Glacier or Amazon S3 Glacier Deep Archive. Amazon S3 Glacier is at a 60% lower storage cost than S3 Standard Infrequent Access. Or perhaps you can use Glacier Deep Archive at the lowest storage cost available at about just $1 per terabyte. Now, let's say you have recreatable data or secondary copies. For example, perhaps you have snapshots or backups that you just want to store in S3 so that it's available, but you don't need the same 3AZ requirement. For this type of data, you should consider using S3 One Zone Infrequent Access, which stores data in a single AZ, but at a 20% lower storage cost than S3 Standard Infrequent Access. And if you have local data processing or data residency requirements where it needs to be in your data center, consider using Amazon S3 on Outposts, which delivers object storage to your on-premises AWS Outposts environment. Finally, what we hear most from folks is that they're often running data lakes or wanting to build a data lake, where data in data lakes often has unknown or changing access patterns. For example, oftentimes in data lakes, we see customers that they have aggregated data from all areas of a particular business unit or all areas of an organization, and they want it in a centralized bucket so that their analysts can access it. But often, when those analysts do access that data, it can be with unpredictable access patterns. Maybe they have time series data and they're looking at data in the past, and so it's not always clear when that data is going to be accessed. So for data lakes, customers often use Amazon S3 Intelligent Tiering, where data placement is automatically optimized based on how that data is being accessed, from frequently accessed data all the way down to archival data. S3 Intelligent Tiering is one of S3's fastest growing and most popular storage classes. And we'll dive into the details of how S3 Intelligent Tiering works in just a few minutes. But to summarize, Amazon S3 has a number of storage classes to choose from for every imaginable use case. Whether you have demanding performance needs, data residency requirements, unknown access patterns, infrequently accessed data, or archival needs, S3 has a storage class that is optimized for your data access, durability, and cost needs. So as I mentioned before, S3 Intelligent Tiering is one of S3's most popular storage classes. For a small monthly object monitoring and automation fee, S3 Intelligent Tiering monitors the access patterns of your data and automatically moves objects among 4 access tiers. So how does this work? First, all data starts in the frequent access tier. The frequent access tier has the same price and performance as the S3 standard storage class. After 30 consecutive days of no access, data automatically moves from the frequent access tier down to the infrequent access tier. The infrequent access tier also has low millisecond performance and is priced the same as the S3 standard infrequent access storage class. This means you get the same high performance and low latency as you would if you used S3 standard or S3 standard infrequent access. And launched just last November, you can now activate one or both of the 2 new archive access tiers. Data in the archive access tiers is asynchronously accessed. This means to retrieve your data, you first need to restore the data. A restore operation moves the data from the archive access tiers back to the frequent access tiers in as little as a few hours. Because data is asynchronously accessed, not all applications are designed to handle this type of access pattern. So customers must opt in into these two new access tiers. You can opt in your data for the entire bucket, or if you have specific objects or prefixes that you want to opt in, you can do that at that level. If you activate the archive access tier, S3 intelligent tiering will automatically move objects from the infrequent access tier down to the archive access tier after an additional 60 days of no access, so 90 days total. Then objects will move from the archive access tier down to the deep archive access tier after an additional 90 days of no access. You have the flexibility to extend this time to automatically archive for up to 2 years. For example, maybe you know you need your files to be available for at least a year, even though they might be accessed. You can extend this time to automatic archive to up to for a year or even up to 2 years. As I mentioned before, anytime an object in the archive access tier or the deep archive access tier is restored, the object is automatically moved back to the frequent access tier, and the process starts all over again. So as a recap, there's no retrieval fees associated with S3 intelligent tiering, and it's ideal if you have changing or unknown access patterns, which we see a lot with data lakes. So what we hear from customers is that oftentimes access patterns for their data change over time. For example, you might be uploading and analyzing log data, where data is frequently accessed to start, and you chose S3 standard because that data is frequently accessed. However, oftentimes, particularly for log data, you access it initially for the first month or so, and then it predictably cools over time and becomes infrequently accessed, or you need to keep these logs around for some cases up to 7 or 20 or maybe even forever, but that data can be archived. So this brings us to the next topic, which is optimizing your storage. And we see two common design patterns. The first is using S3 intelligent tiering, which automatically optimizes, and it's something we just discussed. The second is using S3 lifecycle. In this approach, you can set up lifecycle policies to transition such data into colder storage classes. For example, you might start an S3 standard, move that data to S3 standard infrequent access as it becomes less frequently accessed, and then onto storage class like S3 Glacier Deep Archive, where that lowest cost storage in the cloud. You can also use S3 lifecycle to expire objects in their older versions based on their age. So to recap, lifecycle is a great approach if you have predictable workloads where objects become colder or less accessed over time. So let's recap these two cost optimization strategies. So one of the key things about storage classes and storing your data is that you want to optimize for performance and storage costs over the lifetime of your data. And I said before, we typically hear from customers that their data requirements change over time, and they need to optimize for each part of the data lifecycle. And there are two design patterns that we see. First, customers can use S3's building blocks of storage classes and S3 lifecycle to optimize cost and performance, or they can use S3 intelligent tiering for that automatic cost optimization between the different storage access tiers. Okay, so now that we talked about storing your data, let's switch gears a bit and talk about securing your data. With Amazon S3, security is at the core of everything we do. The buckets and objects that you store in S3 are secure by default, and we give you granular controls to share that access with others. We also have a number of features that you as a customer can take action on to secure your data, like block public access, encryption by default, bucket permission checks, access points, and access analyzer. So in this section, I'm going to highlight a few of these features in the next few slides. So first, S3 Block Public Access. Block Public Access provides controls across an entire AWS account or at the individual S3 bucket level to ensure that your objects never have public access now and in the future. The Block Public Access feature secures your bucket from new ACLs or bucket policies that allow public access, or new objects that have public access. As a best practice, we recommend this feature for all accounts and buckets where public access is not intended. It's easy to set at the bucket or the account level. Access Analyzer is another new feature that monitors your bucket permissions and gives you visibility into public and cross-account access. Additionally, it gives you ways to remedy public access that's not intended or to acknowledge public access that is intended. Access Analyzer paired with Block Public Access provides a great combination. You can use it to identify first with Access Analyzer where public access is or is intended or is not intended, and then with Block Public Access, you can take action on it if that public access is unintended. Amazon S3 also provides default encryption as a bucket level setting to ensure all data stored in the bucket is encrypted. This is another best practices that we recommend to our customers as an added layer of protection. Okay, so now that we've talked about the first two pillars of storing your data and securing your data, let's switch to the third part of our framework, which is protecting your data. With Amazon S3, all of our storage classes provide 11 nines of object durability. And if you choose one of our regional storage classes like S3 Standard or S3 Intelligent Tiering, the data is redundantly stored across multiple availability zones, so it's stored durably even in the event of an AZ loss. That said, there's still a few use cases where customers want additional protection, and Amazon S3 provides features that can help. Specifically, we hear from customers that they want to protect from bad actors or protect against accidental deletes. Other customers have specific governance or compliance reasons and need additional assurances. So with the last part of this presentation, I'm going to take you through the various options you have for protecting your data within S3. So first, let's talk about S3 replication. Customers commonly use S3 replication to provide lower latency data access in different geographical regions. Or they use it for compliance requirements to store copies of data hundreds of miles apart. You can use S3 replication for additional data protection, and S3 replication gives you several options. For example, you can replicate within the same AWS region with S3 same region replication. Perhaps you have a data residency requirement where you want that secondary copy in a different account, but you need to be within a same region. Or maybe you have to replicate data to a different AWS region, and you can use S3 cross-region replication. For example, many customers have regulatory requirements where they need a second copy of their data in a region that's several hundred miles away. So consider using S3 cross-region replication for this type of use case. You can replicate your data from a single source bucket to multiple destinations. For example, if you have a content distribution where you upload data in a single region and that automatically gets distributed to multiple regions around the globe. Or you can replicate data to different AWS accounts or between different buckets with the different object block retention controls. And if you need predictable replication backed by an SLA, S3 replication time control provides an SLA to replicate objects within 15 minutes of upload. So if you are a customer looking for predictable SLA-backed guarantee on your data replication, consider using S3 replication time control, or RTC as we often call it. S3 RTC is designed to replicate 99.99% of your objects within a 15-minute period, with replication typically, though, taking just a few seconds. You get an SLA commitment that says 99.9% of objects will be replicated to your destination bucket within that 15-minute time period. S3 RTC can be applied to the entire bucket or a subset of objects that you can filter by prefixes or specific object tags. You can also use S3 versioning to protect against accidental overwrites or deletes of objects within your bucket. With versioning, each upload creates a new version of the object. So when you make a new upload after the original upload, or a delete is made to an object, it simply pushes the older object down the version stack. You can manage older versions that you no longer need with a lifecycle policy. For example, maybe you want to keep around 3 of the latest versions, and then you can set a policy to delete those older versions as they age. Another data protection measure that our customers like to use is S3 Object Lock. S3 Object Lock is a good way to protect critical objects from getting deleted or overwritten. With S3 Object Lock, you can store objects using a write once, read many model, or often known as WORM in the industry. WORM helps many of our customers with some of their regulatory requirements. S3 Object Lock provides 2 ways to manage object retention periods and legal holds. A retention period specifies a fixed period of time during which an object remains locked. During this period, your object is WORM protected and cannot be overwritten or deleted. A legal hold provides the same protection as a retention period, but it has no expiration date. Instead, a legal hold remains in place until you explicitly remove it. You can set S3 Object Lock on individual objects or as a bucket level setting to apply to all new objects. And that's a wrap. Thanks for listening to Back to the Basics, getting started with Amazon S3.